Hello, my name's Nick Lomax. I'm an Associate Professor at the University of Leeds, and I'm also a Turing Fellow. And I'm going to talk today about my Turing Fellowship project, which is called SPENSER, a synthetic population estimation and scenario projection model. So SPENSER is a microsimulation model for small area population projection and the creation of scenarios for future-looking planning. So the models that we've produced as part of SPENSER have got quite wide utility in the planning and delivery of services. So the problem that we faced was that there is a lack of very high resolution, small area information about demographic change, and in terms of looking forwards, in terms of projection data for use in the planning of services. So what we create with the SPENSER models are very spatially detailed and attribute-rich information, and these data form the basis for input to other models. So for example, the data have been used to look at different land use formulations. They've been input into a agent-based model, which we are developing in collaboration with Arup to look at differences in scenarios for transport planning. They have also been input into a disease spread model where we've looked at the spread of COVID. So the individual agents that have been produced as part of SPENSER have been augmented and then used to assess the different exposures to COVID. And if you look at the links at the very bottom of the slide, the second link there gives you a link out to a paper where there is further detail of that particular piece of work. And more broadly, these models can be used in looking at infrastructure planning. So the figure that you see on the left-hand side of the slide is a range of scenarios under 4 different scenarios of change within an area of England. So there are 4 scenarios: a baseline, a new towns development, an unplanned development, and an expansion development. The idea being that if you have different scenarios of transport, of housing availability, and of job creation, these will have very different impacts upon the distribution of population moving forwards. So the 4 scenarios there show you what happens under those different scenarios of infrastructure investment. That particular piece of work, as well as the wider methodology, can be found in the link at the bottom around the first paper that we link out from there. So one of the key advantages of the models that we've produced as part of SPENSER is that they are open source models, they're customizable. So what we do is we provide the tools that allow users to generate scenarios of population and land use change. So while we've used these models in different application areas, there is a lot of scope and potential for users to customize them and do as they please with them. So for example, we have a module within the models which allows you to have custom internal migration scenarios. So we developed a model which runs on the data analytic platform for infrastructure called Daphne. So available to users to access and use via that platform. And arguably what the models that we produce as part of SPENSER do is they enable better decision making for policymakers by considering demographic change at high resolution. So whereas in the past you would need a specific demographic team within any infrastructure decision-making plan to identify what demand might look like in the future, we've provided a whole suite of tools which allow you to in effect run different scenarios and look at different future options. So I hope that the links at the bottom are useful to understand more about the project. Also coming up tomorrow is a panel session where I'll be talking more about the SPENSER model and its interaction with other models, both as an input and also in the ways that it's been run alongside. So I hope that you can join us and there'll be an opportunity to ask questions and learn more about the project. Thank you very much.